Okay, we're on the last section of this course, which is Unit 16, Lesson 2, Normal Distributions. So the normal curve is also called the bell curve, and it's kind of a distribution that occurs naturally in many situations. So if you take a business class or statistics class, this will come up again. There are lots of different graphs out there, and all the percentages are close, but there is some slight variation. So for our purposes, we're just going to use these percentages and this curve, okay? So what you'll notice is that's 34.1%, 13.6%, 2.1, and 0.1. And you'll notice if you add all of these up, it does not add up to 100%. There are more data values on both ends, okay? So just a little disclaimer, but typically 68% of the data follows within one standard deviation. So the way it works is the number in the middle, this is like a Greek U, that stands for the mean, okay? And it's right in the middle of the curve. It is symmetrical. And each of these, remember, that's the symbol for standard deviation. So when it says 68% of the data, it's because 34% is above the mean and 34% is below. So it's not exact, but when you talk, you don't use decimal place percentages, so that's why it says 68%. Same thing with 95%. If you go 2 standard deviations, so 2 up and 2 down, so from here to here, that's roughly 95%. And then 99.7% of the data, which is almost everything, falls within 3 standard deviations. So that's why we don't have everything accounted for 100%, but most of our data is within 3 standard deviations, okay? So we are going to practice labeling curves and then answering percentages based on this, okay? So if we talk about ISU basketball player, Kelvin Cato is 83 inches tall, and they're telling you it is a normal distribution of the heights. So they tell you that the average is 70, which that's our U, and our standard deviation is 3. So we are going to label the curve. So in the middle, you label your mean, and I want to see the numbers on the bottom. Oops, sorry. Just looked at my screen. And then I want to, when I go up, we're going to add the standard deviations. So if I add 3, and then I add 3 more, and then I add 3 more. So remember, these are all about heights, and these are inches. Just so you know. And then when you go back, you're going to subtract the standard deviation. So minus 3, and minus 3. Okay? And so we know that people can be above that and people can be below, but it's very little. Okay, so that's what we would want. Also, just so you get used to those percentages, I would write those in the middle because you're going to be answering questions about them. And this is what I would want if I say label your curve. All right. And we could go more if we had a 4th dot. Like, you can just keep adding standard deviations. All right? Okay. So let's do another one, and then we're going to answer questions about it. Okay? So now we're talking about downhill skiing. And it says the mean is 150 and the standard deviation is 10. So I'm going to label those. Okay, and then I'm also going to put in those percentages so I don't have to keep flipping back and forth. So, all right. So let's look at our first question. It says, what is the proportion of women's ski lengths that are less than 130? So if I go up here to 130, then less is this way. So we've got 2.1 and 0.1. So if I add those together, we're going to say 2.2%. And then it says greater than 125. So 125 is not actually on our curve, so I'm going to change that to say 140, and I will. Okay, so 140, so we've got from here, and I'm going to add all of those up. So let's see, we get what is the proportion of ski lengths that are between, let's say, 120 and 150? So we're going to add those up. So I've got there, there to there. So those are between. All right, so very long skis are expensive and there are not many people who rent them. What is the longest women's ski a rental shop should carry so that only 2% of customers ask to rent the longer ones? So these are the longer heights on this side, and I want to find out where does 2% happen. So we're not going to find that exactly, but if I'm at 0.1 and then I go to 2.1, that'll be like 2.2%. So that's as close as we can get. So we're going to want to say 170 centimeters. So if we carry over 170 centimeters, that would be for those 2% of the customers. Okay. So remember, sometimes you'll estimate the percentages, and I know that's different in math, but it really just depends on how the question is worded.